Hi, Assalamualaikum. My name is Zulaika binti Abdullah. Today I will talk about Chapter 1, the structure of an atoms. First of all, I will tell you the definition of atoms, molecules, and compounds based on Dalton's atomic theory. Atoms is the smallest unit of matter that can take part in a chemical reaction and which cannot be broken down chemically into anything simpler, constituted of subatomic particles including electrons, protons, and neutrons. Next, a group of two or more atoms bonded together. When two or more atoms of the same element combine together, we call them molecules. For compound, a chemical substance made up of two or more elements bonded together so that they cannot be separated by physical. Now, let's dig deeper into molecule. A molecule is an aggregate of two or more atoms in a definite arrangement held together by chemical forces. These bonds form as a result of the sharing or exchange of electrons amongst atoms. A diatomic molecule contains only two atoms. A polyatomic molecule contains more than two atoms. For ion, an ion is an atom or a group of atoms that has a net positive or negative charge. For a positive charge, we can call it as cation. If a neutral atom loses one or more electrons, it will become a cation. For a negative charge, we can call it as anion. If a neutral atom gains one or more electrons, we call it as an ion. For example, we're going to take sodium. If an atom sodium, it has 11 proton and 11 electron. If the sodium is ion, it will be 11 proton and 10 electron. So it's going to be Na+. These are some examples of cation and anion. Let's move on into the basic structure of an atom. A basic structure is a central nucleus surrounded by electrons which orbit around the nucleus in rings that we call shells. Although we've only shown one electron orbiting here, in reality, all of the electrons would be moving all the time. The nucleus itself is made up of two different types of particles, protons and neutrons, which are packed together in a tight ball. Now, the most important thing to remember here is the structure of the atom that we've just been through. The proton and neutron have the same mass, so we say that they both have a relative mass of 1. Electrons are comparatively tiny and have a mass 2,000 times smaller, which is often written as just very small or sometimes even 0. Charge is a bit different though. Protons are positive and have a 1 plus charge. And you can remember this as both proton and positive begin with a P. Neutron has no charge, so we say they are neutral. And this is even easier to remember because the word neutron and neutral both exactly the same way. Lastly, electron has a negative charge, which is the same size as the positive charge of the proton, so -1. It can be easy to get all of these mixed up, but the best way to remember is that we have positive proton and neutral neutrons. And then we know that the electrons are the only one left, so they must be the negative. Next, we will go to the periodic table. The periodic table and each box in the table represent a different type of atom, which we call an element. So this box here represents the element of O. In the upper left, we call it as a mass number, which is a number of proton plus number of neutron. For a neutral elements, number of proton equal to number of electron. For the lower left, we call it as atomic number. Number of proton in the nucleus. For example, we're going to take oxygen. For mass number of oxygen is 16, while for the atomic number of oxygen is 8. So how are we going to find number of neutron? The mass number minus the atomic number. So we will get the answer is 8. For the electron, it's the same answer as the number of neutron. Moving on to isotope. Isotope are atoms of the same element with same number of proton but different number of neutron. Lastly, 3 rules for assigning electrons to orbital of an atom in the ground state. First, Aufbau principle. Electrons occupy orbitals in order of lowest energy level first. Subshells are filled starting with those of lowest energy. Second, Pauli exclusion principle states that only 2 electrons with opposite spins may occupy the same orbital. Lastly, Hahn rule. When E fills a subshell, each orbital will fill with 1 electron of parallel spin before they occupy the orbital in pairs. An atom tends to have as many unpaired electrons as possible. That's all for my explanation about Chapter 1, the structure of atoms. Thank you.